Alright, welcome back now. We're going to do chapter 24, and this is on planetary geology. And honestly, this is one of my most favorite chapters to cover in this book because I know a lot about planetary geology, especially on Mars. So let's get right into it. Here's an overview of the solar system. The solar system includes the Sun, which is 99.9% of all the mass in the solar system. That really should say 8 planets, not 9, because we demoted Pluto a number of years ago from planet status to dwarf planet status. But we do include their satellites, which means moons. There are asteroids and comets and meteoroids, bigger chunks of rock. So here's the solar system. We have a belt of rocks between Mars and Jupiter called the asteroid belt. And beyond the orbit of Neptune, there's a much bigger belt of objects called the Kuiper belt. And these are icy comets or asteroids ready to come into the solar system. So a planet's orbit lies in an orbital plane. This is similar to a flat sheet of paper. The orbital planes of the planets are inclined as well. Now, most of the planets are in a flat plane. They're within 3 degrees of the sun's equator. Mercury's a little more tilted, 7 degrees. Pluto, not, again, a planet anymore, is highly inclined, 17 degrees, which makes it one of the reasons why it's not a planet anymore. There are 2 groups of planets that occur in the solar system. We have terrestrial and Jovian. The terrestrial planets are Earth-like planets. These are Mercury, Venus, Earth, and Mars. They are small, they are dense and rocky, and have low escape velocities. The Jovian, or Jupiter-like planets, are gas giants: Jupiter, Saturn, Uranus, and Neptune. They are large planets, low density, and gaseous. They're very massive, too. The thick atmosphere is composed of hydrogen, helium, methane, and ammonia primarily, and they have very high escape velocities. Pluto does not actually fit into either group, which is another reason why it was demoted by the astronomers. So here's a picture of the planets drawn to size, and you can see that Mercury is really tiny. Jupiter is really massive and big. Jupiter is 11 times bigger than the size of the Earth, 319 times more massive. Saturn is also a beautiful gas giant planet, and then out beyond that, the icy giants, Uranus and Neptune, mostly methane, making that blue color there in the atmosphere. So planets are composed of gases and rocks. The gases include hydrogen and helium, the primordial gases in the universe, and rocks including silicate minerals and metallic iron. And then we have ices, and this is really out in Jupiter, Saturn, especially Uranus, Neptune, way out past the sun, about 4 billion miles. They include ammonia, methane, carbon dioxide, and water ice. Now, how did the planets come to be? Well, we have a theory. It's called the solar nebula theory. And this theory states that the planets formed about 4.5 or 5 billion years ago, and it condensed out of a gaseous nebula that was spinning. As the planets formed, the materials that composed them separated. The denser stuff, the iron and nickel, sank towards the center, and the lighter elements like hydrogen and helium went outwards from the solar wind out to form the gas giants, where it was colder. So as the planets formed, these materials started to separate, and we call this differentiation. So the heavy metals like iron and nickel went to the Earth's core, and then the lighter stuff came out to the crust. Now, due to the surface gravities, Venus and Earth retained their atmospheric gases, but however, due to the frigid temperatures, the Jovian planets contain a high percentage of ices, and in fact, Jupiter still has not cooled off from its formation 4.5 years ago. Let's take a look at Earth's moon. It's about 2,100 miles across, unusually large compared to the Earth. Most moons are small compared to their planet it goes around. The density, 3.3 times that of water on the moon, comparable to Earth's crustal rocks, and perhaps the moon has a small iron core. The gravity on the moon is 1/6 that of the Earth, and it practically has no atmosphere. It is geologically dead, which means the tectonics are no longer active, and the surface gets bombarded by micrometeorites from space, which gradually make the landscape smooth. Here are some surface features on the moon. We see in the middle a crater The crater was so big and the impact so massive it formed a central peak. This is kind of like throwing a rock or a boulder into a lake and you see a splash come back out of the lake. There is, in all directions, these ejecta planes where the stuff inside the crater got spewed out along the lunar surface, and we see these lines called rays on the moon. They're lighter colored. Now there are two types of terrain on the Earth's moon. One is called Marya, which is Latin for sea. It has dark regions, fairly smooth lowlands, and originated from asteroid impacts and lava flooding the surface. If you're familiar with the Ozarks, it's much like Table Rock Lake in the 50s flooded the basin there to form a lake. So there are cracks in the surface of the moon, and the lava would flow up through those cracks and fill in the low-lying areas. The other type of surface feature on the moon are the highlands. These are the mountains, bright and densely cratered regions. They make up most of the moon, make up all the backside of the moon, the side we can never see, and they are older than the seas or the Marya. And then we have craters, of course, the most obvious features on the lunar surface. We mentioned ejecta. That's the stuff that comes out of the crater and flows into, sometimes in a linear pattern called rays. The surface of the moon is a very fine, dusty powder that we call lunar regolith. It covers all lunar terrains. It's gray, composed of igneous rocks, breccia, glass beads, fine lunar dust. In fact, when we were going to the moon in the 60s, we were worried that the astronauts would actually sink into the ground, so we had to send some spacecraft up first to prove that they wouldn't. So how did we form the moon? Was it formed at the same time as the Earth? We don't think so. The hypothesis suggests that a giant asteroid, maybe the size of the planet Mars, 1/3 the size of Earth, collided with the Earth in a glancing blow to produce the moon. The older areas have a higher density, the younger areas are very, very smooth still. Now let's change topics for a minute and talk about a brief tour of all of our planets. Let's start off with the innermost planet, Mercury. It takes 88 days for Mercury to go around the Sun, and it's got a very elliptical orbit. Now that we're not considering Pluto anymore, it is actually the smallest planet of the 8. Virtually has no atmosphere. Lots of cratering by highlands. Also has some vast smooth terrains. It's very dense. It has a very large iron core as compared to the rest of the planet. And it revolves quickly. 88 days. Here's a good picture of Mercury. You can see the different cratering on it. And the cratering is so heavy on Mercury, even though it's so small, because it's so close to the Sun. The Sun's gravity is pulling everything in towards that area, and it's getting hit all the time. Next up is Venus, second to the moon in brilliance. It's visible in the early morning or early evening skies, similar in size to the Earth, similar in density and location in the solar system. One common misnomer is that Venus is Earth's sister planet, and it really isn't. The only thing that it's comparable to is the size of the Earth. Many things very different about it. One of those things is the fact that it's shrouded in very thick clouds. The atmosphere is 97% carbon dioxide, and the air pressure is 90 times more than what is on the Earth. If you were to go there, you would be crushed immediately by the atmospheric pressure. Now, because Venus has a large layer of clouds around it, we have not been very successful in going to the surface to get pictures of the surface. In fact, the United States has never done that. The Russians did send 2 spacecraft to land on Venus, but as you can imagine, these Venera spacecraft, they melted pretty quick because the surface temperature is about 900 degrees Fahrenheit from this. It's a runaway greenhouse effect. We've talked about climate change on the Earth and the greenhouse gases. Well, on Venus, that's kind of like where the Earth is heading to someday, and down the line is very thick and hot atmosphere. Actually rains sulfuric acid rain on Venus. So what we did in the United States is we sent the mission called Magellan, and it was a radar and laser beam satellite that orbited Venus for quite a number of years. 80% of the surface is subdued plains that are mantled by volcanic flows. We know Venus at one time had volcanoes on it. A low density of impact craters because of the lava flows and because of the fact that it has a very thick atmosphere to burn up those meteors that might hit. The tectonic deformation must have been active during the recent geological past, so it only recently became dead. And there are thousands of volcanic structures on Venus. So this is a color-enhanced, computer-generated view of Venus as mapped by the Magellan spacecraft. Typically, the bluer are lower regions, and the brighter colors are higher regions. Here's a picture from Magellan that shows lava flows from volcanoes on Venus. One of my favorite planets is Mars, called the Red Planet. It does actually have an atmosphere around it. It's only 1% as dense as the Earth's atmosphere and primarily consists of carbon dioxide, another greenhouse gas. So it's kind of like the opposite of Venus. Now it is pretty cold on Mars. It's farther away from the sun than we are. And so at the poles, in the wintertime, it gets to about minus 200 degrees Fahrenheit. Polar caps are water ice covered by a thin layer of frozen carbon dioxide. And so one polar ice cap is water ice. The other polar cap is dry ice made of carbon dioxide. Now we do know that it has an atmosphere and it has dust, so it has a lot of dust storms with winds up to 170 miles per hour, and we have seen this from our spacecraft. In fact, a little bit of history here. One of my former NASA interns, actually her job now with NASA is to land the spacecraft on Mars. That's her job. She tells them where to land. Mars has a lot of different volcanoes on it. The largest volcano is called Olympus Mons, or Mount Olympus. Olympus Mons is 90,000 feet tall and the size of the state of Arizona. That is 3 times bigger than Mount Everest on the Earth. Now, why is it that such a large volcano can exist on Mars? It's because of the same principle we have in Hawaii, a magma chamber, a hot spot coming up through the surface, but the plate that Hawaii sits on is moving. Well, on Mars, the plates don't move. It's geologically, tectonically dead. And so the same spot just stayed there and grew and grew and grew over billions of years. It does have several canyons. One is called Valles Marineris, or Mariner Valley, from the spacecraft Mariner 10 that examined it. Some of these canyons are even larger than the Earth's Grand Canyon. And Valles Marineris is such a large canyon, it would actually strung from Las Vegas all the way to New York City. That's that big. 3,000 miles long. So here is Mount Olympus, Olympus Mons. It is the size of Arizona, and it's a shield volcano we just talked about in Chapter 5. You can see the caldera there at the top. We know that on the surface there are stream drainage patterns formed in some of the valleys. There are no bodies of surface water on the planet. However, just very recently, the Curiosity rover did find 2% amount of water trapped in the soil in the upper layers of the ground. We do think that at one point Mars did have water oceans. Possible origins could include past rainfall and surface material collapses at the surface of ice melts. So we know that in the past the atmosphere of Mercury was very different that could support water. And here's the cool thing is anywhere on the Earth where there's water, there's life. And so there's the question of, did Mars ever exhibit life because of the water that used to be on it? Very good question. Here are some gullies from one of the missions that's at Mars right now, one of our orbiters, and you can clearly see these gullies as the lava or water came down through the canyon walls and made these gullies. Very beautiful picture. Moving on to Jupiter, it is the largest planet. Like I said, it's 319 times the mass of the Earth, 11 times bigger in size. It is 2.5 times more massive than all the rest of the stuff in the solar system except the Sun combined. If it had been 10 times larger, it could have been a small star. Rapid rotation, it goes around very fast. A day on Jupiter is just less than 10 hours. So we've actually sent a probe into the atmosphere of Jupiter from the Galileo spacecraft. We did that in the 90s. And we see these light and dark areas. The dark areas are called belts. Those bright areas are called zones. And so the zones, the bright areas, is material rising up to the top, and the dark areas, the belts, is material settling back down into the planet through a process called convection, because the planet is still heated up from its formation 4.5 billion years ago and is still cooling off. Kind of like a pot of boiling soup on the stove. Has this banded appearance, multicolored, the belts and zones. They are aligned to the equator on Jupiter and generated by wind systems. Now, one very interesting feature on Jupiter is this humongous low-pressure system called the Great Red Spot. It's in the southern hemisphere and it counterclockwise rotates. It is similar in scope to a hurricane on the Earth, except that, on the Earth, a massive, massive hurricane like Hurricane Katrina may take up the entire Gulf of Mexico. The Great Red Spot is actually 3 times the size of the entire Earth combined. So it's a very large feature, and we know it's been there for at least 400 years because Galileo saw it with his telescope that he invented in 1609. We think the surface is thought to be a gigantic ocean of liquid hydrogen, helium. Halfway into the interior, the pressures get to the point where the liquid helium and hydrogen actually form a different process of themselves that is metallic in nature. And then in the very center, there's probably a rocky or metallic core down there in the center. Now this slide, I'm going to tell you, is a little out of date. It's from the publisher, but the moons, there are over 67 moons now around Jupiter. The largest 4 moons are Callisto, Ganymede, Europa, and Io, and these were discovered by Galileo. And so we call these the Galilean satellites. Callisto is the outermost Galilean moon, lots of collisions. Ganymede is the largest satellite, one of the largest satellites in the solar system, and it's covered in craters. Then we get to these really 2 interesting moons. Europa is the smallest moon, but is actually covered in a 60-mile thick coating of ice. And we believe that underneath that ice is liquid water. And remember what I said, where there's water on the Earth, there's life. So is it possible there could be life in that ocean underneath the ice of Europa? And then we have this strange planet called Io. Io is the innermost Galilean moon, and it is volcanically active. And the reason for this is because it's so close to Jupiter, and Jupiter is so massive that actually the size of Io changes by 6 miles as it goes around Jupiter. And that compression heats up the core and generates volcanic activity. And instead of lava flows like we have on the Earth, it actually spits out sulfuric lava and steam. And we've actually seen this with the Voyager spacecraft and the Galileo spacecraft. Here's a picture of Io. And here's a geyser going off on Io. Pretty cool. And that's sulfuric acid coming out of the volcano. On to Saturn now. I think the most beautiful, beautiful planet of all. You look through it in a telescope and it looks fake. It looks fake to me. Similar to Jupiter in atmosphere, composition, and internal structure. And Jupiter does have a very small, thin ring system around the planet, but Saturn's known for its rings. The most prominent feature, and it was discovered by Galileo in 1610, very complex. It's not actually a solid ring. It's actually small particles all orbiting in a flat plane. So we call these moonlets. Most of the rings fall into 2 categories and are thought to be debris ejected from moons. The origin of that is still being debated. So here's a picture from the Cassini spacecraft around Saturn, still there as of 2013, going around Saturn. And you see the ring belts and you see Saturn. Saturn also has belts and zones that rise and fall, but it's a little cloudier because of a haze in the atmosphere from the sulfuric acid. And in the middle of the rings, we see this dark line going through it, and that's called the Cassini division, as discovered by Giovanni Cassini, and it's called the Cassini division. And there are some moons that reside in a resonance cycle in that band right there. Saturn also has a dynamic atmosphere. It's constantly moving. Has large cyclonic storms. It has 30, maybe 35 named moons. The biggest of them is Triton. We have actually landed a spacecraft on Triton when Cassini got to Saturn a number of years ago. We sent a probe to land on Saturn. And it is the second largest moon after Ganymede in the solar system. And Triton is the only moon to have a substantial atmosphere. And we actually landed on it. We landed on a soft beach near a lake of methane. Methane's extremely cold. Now onto the ice giants. We have Uranus and Neptune. They are nearly twins. They rotate on its side. They have rings to them, and they were not actually discovered until 1979. They were discovered by a graduate student. Large moons with variety trains. So here's Uranus. Uranus has probably been collided with something large sometime in its past and tilted it about 97 degrees to the horizontal. And it does have these rings. And the rings were discovered by a graduate student in the 70s. When a star would go behind the rings, he would see the star blink out and then come back to light. So that was the discovery of the rings. We can't see them from Earth. Neptune's quite interesting, and it is the farthest planet out. It's over 4 billion miles away. It's got a very dynamic atmosphere. In fact, it's actually one of the windiest places in the solar system. They have some venticular clouds that are white and wispy that go around at 800 miles an hour. And on Neptune, we used to have a great dark spot, similar to the great red spot, but just dark. And above the dark spot was these white wispy clouds going around at 800 miles an hour. Now, a side note, in 1994, there was a collision of a comet into the planet Jupiter, and it created some large dark spots the size of the Earth. When we looked at Neptune in the mid-21st century, around 2005, 2006, one of my colleagues, Dr. Heidi Hamill, she was the one working the Hubble Space Telescope during a collision with Jupiter in 1994, determined that the great dark spot had gone away. And so there's a theory, at least in my mind, that the great dark spot could have been an impact feature from a comet recently hit it. We went to Neptune in 1986 with Voyager 2. It has more than 8 satellites, probably about 14, 15 satellites, and of those, Triton, not to be confused with Titan, is the largest Neptunian moon. It orbits in the opposite direction that all the planets travel, so it's probably been collided at some point, and it's got the coldest surface temperature of anything in the solar system. Triton actually has geysers of nitrogen on them. So here's Neptune, the great dark spot there. It's now gone. There's a new great dark spot in the northern hemisphere. And those white clouds are moving at 800 miles an hour. Triton, again, the largest Neptunian moon, has an atmosphere of mostly nitrogen with a little bit of methane in it. Volcanic activity of sulfuric acid, composed largely of water ice and covered with layers of the solid nitrogen coming out of the geysers of liquid nitrogen and methane. That's it for the planets. And then we have some other stuff in the solar system. We have asteroids. These are large rocks that lie mostly between Mars and Jupiter. There are a number that come near Earth. These are small bodies. The largest is called Ceres, and actually Ceres got promoted to a dwarf planet instead of an asteroid when we demoted Pluto. About 620 miles in diameter. It's very large for a small rock. Has elliptical orbits and eccentric orbits. The irregular shapes and the origin of these are not known. And then we have comets, often compared to large, dirty snowballs. These are made up of frozen gases, dirt, rock, ice, and organic material. The frozen gases vaporize when it's near the sun, and they produce a glowing head called the coma, and most of them develop a tail or two that points away from the sun due to the solar wind. One could be a gas tail, and one could be a dust tail. So here is a picture. This is probably Hale-Bopp in the picture, I'm guessing, in the 1997 era. The dust coming off of it. You see straight out, you see the ion tail, the gas tail going straight directly away from the sun, and then trailing behind the comet is the dust tail. And as you can see, as the comet comes near the sun, the tail changes orbits and changes directions quite rapidly. The origins are not well known of comets, but some of them probably formed out of the Kuiper belt. And there are short period and long period comets. The most famous short period comet is Halleys Comet. Every 76 years it comes by. It was last seen in 1986 and will come back in the year 2061. It has gone by so many times that it's just gotten worse and worse every time it comes by. In 1910, it was very brilliant, but in 1986 it was kind of a dud for what we thought it might be. And so when we in 2061, when it comes back, it may not be much of a show at all. Here's Comet Hale-Bopp that we looked at. I've done some studies on this comet. One of the larger comets we've seen in recent history. And now we talk about the meteoroids. And these are small chunks of rocks, much smaller than asteroids. And the meteoroids come in three flavors. We have meteoroids similar to asteroids. They are in space. We have meteors, which is when that piece of rock starts to enter the Earth's atmosphere and glow, like a meteor shower, a falling star, if you want to call it that. When a meteor hits the ground, it's called a meteorite. Now, here's the common joke in astronomy. What do you call a rock that's on the ground that's not a meteorite? We call it a meteor wrong. And there's your joke for the day. There are different types of meteoroids. They come in iron, stony, or a combination of the two. Here's a beautiful, probably the most preserved crater on Earth. It's called Meteor Crater, Barringer Meteor Crater in Arizona. Landed on a guy's farm 50,000 years ago. The guy bought the land and said he couldn't farm on it, so he turned it into a tourist attraction. And it is located between Winslow and Flagstaff, Arizona, and northern Arizona. This is actually where the Apollo astronauts trained. One of the things we didn't know about this crater for a while was, is it volcanic in nature, or was it from an impact? It wasn't until the 1950s when a doctoral student named Gene Shoemaker at Caltech in California, in Pasadena, thought, well, if I go to this crater and I can find what I'm looking for, I can tell what it is. And the thing he was looking for was a type of quartz rock called shocked quartz. And shocked quartz only forms when there's an immense amount of heat and pressure. We're talking billions of tons of pressure and millions of degrees of heat. And sure enough, he found what he was looking for. He wanted to go to the moon and walk on the moon and look for this type of thing, but he had some medical conditions. And so he trained the Apollo astronauts in the 60s and 70s down there at Meteor Crater. On a sad note, Gene Shoemaker died about 10, 12 years ago, actually in a freak accident in the Australian outback as he was going looking for craters. And got impacted with another car on a one-lane road, and they both just happened to turn the same direction, and we lost Dr. Shoemaker. Dwarf planets, kind of like Pluto and Ceres, new class of objects. I will tell you, I think the next time the astronomers get together worldwide will be in 2015 in Hawaii. And by that point in time, we have a spacecraft called New Horizons that's going to be arriving about that time at Pluto. And since then, since the vote happened, there's been 3 or 4 more moons found around Pluto, and a little bit of an atmosphere that's frozen out. I think in 2015, due to some politics, we'll see Pluto become a planet again. Don't hold me to that, but if I had a vote in the nature, I would vote for it to be a planet again. It seems to have all planetary characteristics. That's it for chapter 24, and we'll see you next time.